So now that we have an understanding on how abstract data types work and how they work with data structures, and that's basically a good overview of how data abstraction works, let's talk a little bit, go over a little review of Java classes. So Java classes use something called encapsulation. And encapsulation is basically a part of object-oriented programming. And what it does, it combines any abstract data type's data with the methods that's used on it to form objects. And like we used in the previous example of array lists, the abstract data types methods, which were outlined using an interface, were implemented within the data structure, and then any kind of data before that was hidden from the programmer. So it basically hides things from programmers and only allows us to access some things. And this is how we combine classes within our programs. We can only call on certain methods, and we can't access certain data, say instance variables and stuff like that. We don't usually have the ability to access that, and it basically allows us to combine those classes together and use them. So let's go over a few basics. So a class is a new data type. So every time you define a class, you can use it as its own data type. So it has data fields. So right at say this is a diagram of how a class looks. Here we have the top of it, and here is all your data fields. And then here is all your methods. And that's usually a basic outline. And your methods include what are called constructors, and these are what actually create your object. And there's a few types of constructors. And basically the one that's used, I guess, the most often is the default constructor. And the default constructor has absolutely no parameters on it. It just gives each of your data fields default values. And then there's also the compiler generated default, which has no parameters and usually does not assign values to your different data fields. So a client basically is a program that uses all those classes. So we wanted to use one part of my program had one class, and then say I needed to use this class. Okay, now this is the client of this class, and this class uses this class. And then one more thing is garbage collection. And anytime an object points to something that's null, it's usually scheduled for garbage collection, and it will just get rid of that thing. So that's very simple. And those are some basics of it. So now let's go over a little bit of what inheritance is. So say you had an object, say something like very general. So let's use the example of animals. The animal is what's known as the superclass, and this contains contents that are similar between different subclasses. So the superclass has animal, say it has stuff like my animal has a heart, my animal has skin, right? Those are very general things about an animal. Now the subclass are things such as mammals, or reptiles, or fish. And wait, what are the sea creatures? I don't know. Sure. I'm not a biology guy. So subclasses will inherit all those traits. It'll take what's the skin, it'll take the heartbeat, it has all those things, and it will allow you to add more basically. So say you had just basic stuff up here, and you didn't want to get cluttered down here, because you're going to be repeating a lot of stuff if you only had the subclasses. So say I wanted to reduce the amount of code I use, then I put it to my superclass to hold most of the data right here, and then subclasses will add on to it. And that's basically how inheritance works. And anytime you want to access something from your superclass, you really just use this keyword super. And every time you create a subclass, it needs to, in its constructor, you need to call the superclass as well to make sure that you access it, or that you create a superclass object, and you also to make sure you extend it to your superclass up here. So, moving on, let's talk a little bit about equals. So, by default, any class will have an equals method, and all that equals method does is basically check to reference if it's the same object. It checks the memory location and it sees, okay, are we using the same object here? Cool, we are, that's true. If we're not, it's false, basically like that. So now, what if you want to override the equals? When you override the equals, okay, now it checks the values of the data fields. So basically, it will look, say you had a number up there, say you had a string, and then you created two objects of it. It will check if those number and string match, and then it will also check if it references the same location. If it references the same location, okay, cool, it's already the same object, nice. But if it doesn't reference the same location, okay, let's check if they have the same values. If they have the same values, then we'll call it the same object and they're equal to each other. Cool. So one thing we mentioned earlier was interfaces. And all an interface does is supplies methods and constants to a class, but it doesn't allow the interface itself doesn't actually implement how the method is created. So let's use an example here of a chef. So my chef wants to know how to bake. So here I've created an interface called baking. Now interface itself is not a class, so here's how I define that it's an interface. I just have to write the word interface in front of it. Now any method that's outlined within my interface is assumed to be a public method. So all I have to do is write void bake as one of my methods. Obviously there's going to be more like mixing and cracking eggs, stuff like that. But all I wrote down here is bake. Now my chef, okay, he knows that he needs to bake stuff, right? So now he's going to implement baking, and he's going to learn how to bake and create an implementation on how to bake something. So he needs to turn his oven to whatever temperature, to X temperature. That'll be a variable that changes, maybe with a parameter, and then turn to X temperature, and then he needs to learn how to watch his baking material rise to proper stuff. Yeah, I know how to bake, guys. So that's basically how interfaces work. A class implements the interface and then it overrides this method to allow so that the implementation can be written. Okay, now I think that's the last thing. Yep. Alright, finally we have exceptions. So exceptions are used to catch errors, and this is probably one of the more effective ways to catch an error. So there's two parts to an exception. One is the throw and one is the catch, and then there's also a try. So wait, that makes no sense. What the hell did I say? There's three parts, sorry. There's three parts, and there's the throw, the catch, and there's also the try. These are all different types of statements. And here first we're going to talk about the try block. So basically the try block looks at a statement that might throw an exception. So we look at something and say if it might get an error, we put it in the try block, and then after that we'll use a catch statement to see, okay, here we have an exception, let's see if we can catch it and fix it somehow. That's basically what the catch, or we tell the user, hey, you need to fix this. So that's basically how try and catch blocks work. So this is a basic look at how a try block looks, and this is how a basic look on how, oh my god, what happened? Okay, here's a basic look on how catches work right here. So you can see that the catch has an exception class identifier. This is basically the exception that is thrown, say, by this thing. So this is the throw statement, and it basically uses this to throw an exception to our catch statements. And here we have a different statement, and this basically can throw at any time a different class or an exception class. So this is a little basic overview on data abstraction and then different classes, concepts of classes in Java. I hope this taught you well. If not, let me know. Then I'll see you next week.